Hello everyone, I am Harpreet Singh from DSA Batch 6 and today I am making the video presentation as a part of Girl Script Winter of Contributing. So today's topic is operations on doubly linked list deletion. So we will be discussing about the different cases of deletion in doubly linked list. So there are three cases. The first one is deletion in doubly linked list from the beginning. Second one is deletion in doubly linked list at the end. Third one is deletion in doubly linked list at a specified position. So we will be discussing it one by one and clear the concepts that being used here. Okay, so let us discuss the first case. First of all, we can check the underflow condition. If my head is not pointing to any node, then I can simply say it is an underflow condition. I can't delete anything. You just exit the function. But if it is not the case, then what I will be doing is I will assign the pointer as head so that it can point to my first node, which I need to delete. I can make head point to its next so that it comes to the second node now, or if it is not, if there is no second node, then it comes to null now, and make the heads previous as null so that this link get broken down, and make the ptr next as also null so that this link also get broken down, and this node will get automatically deleted and we can exit the function. Then comes the second case, that is we need to delete the last node. So for that also we will be checking the underflow condition. But if it is not the case, then what we need to do is we will assign the temp as head and we will be traversing till we get the last node, that is temp next is not equal to null. You should make the temp as temp next, next, and so on till we get the last node. Okay, when we will be getting the last node, then what we can do is in temps previous next make it as null and temps previous also null so that this links get broken down, this link get broken down, and so automatically this head will only be pointing to this node and this node will get deleted. So this was the case. Last but not the least, the case that comes is deletion in doubly linked list at a specified position. So if I give the position as 1, first node gets deleted. If I give the position as 2, second node gets deleted. If I give the position as 3, third node gets deleted, and so on. Okay, so we will be checking the underflow condition here as well, and if it is not the case, then what we can do is we will assign the ptr as head and we will repeat the process till position minus minus is greater than 1. Why is it so? So if I give the position as 2 here, which is the specific case here, so what I can do is 2 minus minus is greater than 1. So 2 is greater than 1, the loop will run. Then 2 becomes 1 for the next case. Okay, keep that in mind. So PTR will be PTR's next, so PTR will come to second node. Then the position has become 1. 1 is greater than 1? No. And position also becomes 0 as well. So yeah, it will not run and it will be pointing to the second node for the position second. So yeah, you need to identify these conditions by dry running. Okay, if you will dry run, you will easily get that what I am saying. Okay, then when you will get the ptr, just make the ptr's previous as some other pointer at 10 for the simplicity of understanding, um, and make the forward as ptr's next. So temp will be pointing here and forward will be pointing here and ptr is pointing here. So what I need to do is I need to make a connection between temp and forward and delete this ptr node. So what I will be doing is I will just say that in temps next put the forward and in forwards previous put the temp, and makes the ptrs previous and next as null. So basically this link has been established and this link has been broken down. So this node will get deleted and yeah, I can just simply exit the function. So these were the cases. Now let us come to the complexity analysis part. So what will be the time complexity for deletion at beginning? It will simply take order of one time, constant time. Why is it so? Because we don't need to traverse the linked list for that purpose. We can just play the game with the pointers and we can delete the first node. So that will take constant time. If I need to delete at last, yeah, I need to traverse till the last node. So it will take order of n time. If I talk about the last case, that deletion at an index or at a position, then for the best case, it will take order of one time, that is in the starting itself, right? And for the worst case, like in the end or in the middle or somewhere in between, it will take order of n time. If I talk about the space complexity part, so in deletion as well, doubly linked list, will take constant time. It will take order of 1 time, and as we don't require any other space. So let me talk about the menu driven program that I have created. Okay, yeah. So first of all, I can import the scanner class, and then I have written the class as same file name as it is stored in. Then what I can do is I can just declare this public static scanner SCN, so that I can just take the input from the user. After that, I am declaring a DLL class where every function of the W linked list will be present. In that, I have made a private node so that the client cannot access my node. Only the function inside this class can access it. So that is OOPS concept that we should use and keep in mind. What will be there in the node, that is data, next pointer, and previous pointer. I can make a constructor where whatever value I will pass, it will be stored, and next and previous will be null. Okay. Then again, after declaring the node class, in the DLL class only, we are having a head pointer as private, so that the other things cannot access it. The we cannot access it from main, but we can access it from the functions inside this class. So yeah, let us talk about insertion. um, why insertion? Because for deletion I need to make a doubly linked list first of all. So yeah, I am having an insert first node function where I will be inserting the node at the beginning. And yeah, the same thing which we can use here is we can make a public type function so that we can access it from main. It will receive the integer type value, and I will create a new node with that value with my constructor, and I will pass it to my private function which will do the main work, and main cannot access this function. So yeah, I can first of all calculate the size with the size function. That is a simple one to understand. Hmm. So we will just assign the current as head. If assign the count as 0, while current is not equal to null, count plus plus, and current will go to current next. So yeah, this is a simple function for calculating the count. I can return the count. It will return me the size of the doubly linked list. Okay, if it has given me the size of the doubly linked list, so if that size is 0, this means that uh, the head is not pointing to anything, so this dot head should be node. All right, then what we can do is the simple things which we have discussed. Nodes next will be, yeah, this nodes next will be this dot head, and this dot head dot previous will be node, and this dot head will point to node. So these are the things that are easy to understand, no need to go in detail. Then let me talk about the main functions here, that is deletion and starting. So if my head is null, you can just print the underflow condition and return -1 from here. If it is not the case, then what you can do is point the current at head. Head will go on to the heads next. Heads previous, make it as null. Currents next will also be we will make it as null, and we will return this currents data. So the node will get deleted, and we will also be returning the data of it. Yeah, then we can delete the node from the end. So what function we will be using is, first of all, we'll be checking the underflow condition, and if it is not null, head is not null, then what we can do is we will be having a current pointer starting from head, and we will go on till currents next is not null. Current will be currents next. Then when we will get the current, we will be, for simplicity purposes, I will be having a previous that will be pointing to currents previous. So basically I have my current is pointing to the last node, and previous is pointing to the second last node. So we will make the previous next as null and current previous as null. So the node will get deleted, and we can just return the current data. So if I need to delete a node at a specified position, that is the third case, then again I will be checking the underflow condition, and if the doubly linked list is not empty, then what we can do is we can calculate the size of the doubly linked list, and we can have a index is invalid exception. If my index given is invalid, like it will check that this position lies between 1 and 1 to size, then only I can delete, otherwise I can't delete. Okay, So this was a simple function. So let us see what this function will do. Yeah, index is invalid except exception. It will receive the index, left range and right range. If my index lies less than left range or it lies greater than right range, then simply say it index is invalid, return true. Otherwise, if it is valid index, return false. Okay. So yeah, if it is true, it will return -1. No need to do anything. But if it has written false, then come here. Check if my position is 1, then simply call your deleted starting function. If it is size, then simply call your deleted ending function, which you have already created. These are the first two cases. We should also check that. Otherwise, the third case which comes into the picture, which is the main thing here to discuss, is point your current to the head and go on till this position minus minus is greater than 1. We have discussed this condition, and we can say currents equal to currents next till this condition is true. Then when we will reach the specified node which you need to delete, your current will be pointing to there. Make your previous as current previous and forward as current next. So previous and forward will also be at their exact positions, and we need to make a connection between previous and forward. So we'll simply say previous next as forward and forwards previous as previous, and currents next and currents previous will also be null, and we can simply return its data. So the node will get deleted. Okay. So one more thing which we should also discuss is a toString function. I have written this for displaying the doubly linked list. For displaying it, what I have done is I have make a string builder. For the traversing part, I have make a pointer that will start traversing from head. First of all, in the string builder, I will be appending this square brackets, opening square brackets, and then we will traverse till currents is not equal to null. We will append its data, currents data, and if currents next is not null, then only assign comma and a space. Otherwise, if it is currents next is null, that is the last node we are talking about, don't do this thing. And yes, current equal to currents next for the traversing purposes. And then in the end, when you will be done with your traversing, just append the closing square brackets, and this return this string builder, convert it into a string so that you can have a string result. Okay, so let us talk about the main function. So yeah, for the DLL class that I have made, in which every function was there. Okay, everything was there in this DLL class, you can see here. Okay, so for that purposes I have made its object so that I can use it. I can use the public functions here in the main, and I'm having a do while loop simply for making the program as menu driven. First case, it will be deletion at beginning, second deletion at the last, third deletion at an index, fourth one is display the linked list, which we will do from the toString function, insert at the beginning, and you can just exit if you want. You will take input from the user, whatever option he or she wants to select. Accordingly, we have a switch statement for the 1, 2, 3, 4, 5 or a default case, and it will run till while true. Okay, because we have a default case to exit, so yeah, we will be going till while true, and if the user input gives us 6 or something else, we will exit the function, and accordingly we have called the conditions simply. So let me run this program. Okay, so here you have the choices. So let us start inserting something. I will insert 10, I will insert 20, I will be inserting 30. Okay, so now I can execute the case. First of all, I should display the linked list, how it is looking. Okay, you can see 30, 20 and 10. So if I suppose want to delete the node from a specified position, that is 2. So what I will do is I will select the third case. I will enter the index as 2. Okay, so it says 20 was present here and 20 gets deleted. So if I display the linked list, so you can see 20 has been deleted. Then you can say deletion at the last. So as 10 was present in the last, 10 gets deleted. Fine, you can display the linked list for checking. Yeah, You can see 10 gets deleted. Okay, and then you can just say deletion at the beginning. All right, let me check this. So yes, as you can see, the error is there. What error is it? So let us also see how to resolve an error. We have seen that exception in thread mean cannot assign field previous because this dot head is null. Okay, so what mistake that we have done was, um, yeah, when I have assigned heads to heads next, so now as it is pointing to the next node, if there was only one node present in the linked list, then head will be null now. And if head is null, don't do this task because we can't do that. If head is not null, then only we can assign heads previous as null, na? Otherwise we can't do that. So we need to put this condition as well. So yeah, these problems, these errors will come, and you will then only you can make your program good. Okay, so let me run again. Okay, 1 second. Okay, so let me insert one node only, that is 10. Let me display it. So 10 is present. So the case where we were failing, let me check that, delete at the beginning. So 10 gets deleted now with no problem, and you can display the linked list. It is empty now. So all cases have been discussed, and we have also encountered the error and we have solved it live. So that is also a nice thing. We should know each and every aspect of the program. So let me exit this, and yeah. So thank you very much for watching my video so patiently. I hope you enjoyed it. If you have any doubts, you can just give me a comment. I will try to resolve that. And the code of this has been given in the description. You can check it out. Thank you very much.